Hello, I am Richard Zang, Senior in Aerospace Engineering.
And I'm Elliott Killian, a senior in horticulture and a local elected official.
And today we are representing our venture, BluHouse, in which we are replicating the water cycle in a closed-loop environment.
So our idea is closing the loop in greenhouses to make them more sustainable for low resource farming.
So this is a complete schematic of our system, in which we will now go into detail. So the first step is, of course, to water the plants. And then after you water the plants, the water evaporates into the air. And then after that, it condenses onto the sides of the greenhouse as well as underneath the tables. Then the last step, the most important step, is the water pulling step. And by doing this, we'll be having a PVC pipe that runs lengthwise at the top of the greenhouse and slowly drips water down the sides of the greenhouse. And by a snowball effect, it collects the water on the sides. As the water runs down, it clears space on the sides for sunlight to seep in, as well as more surface area for water to condense on.
Let's investigate the problem. Plants need sunlight and water to grow. We grow plants in greenhouses to optimize growing conditions. Continuously adding water leads to high humidity, condensation, and plant diseases. The high humidity blocks sunlight by causing water droplets to form on the walls. This requires ventilation. Ventilation then requires more heating due to the air escaping the greenhouse. A typical greenhouse can expect to spend $8,000 a year in heating cost. Plant diseases like molds are common after the relative humidity exceeds 85%. Only 2 fungicides are allowed for food production. These 2 are limited and resistance have been observed. Can you imagine watering your plants, having excess water be on the ground, which causes less sunlight, lower yields, then causes diseases which you have to pay fungicides to buy, which cuts in your cost? This system is absolutely absurd.
So our goal is to replicate the water cycle. However, in nature, trees play a large role in the cycle by taking up the water, then evaporating through a process called transpiration. By doing so, it actually speeds up this cycle. So why don't we create an artificial leaf to replicate that process? And by doing so, it would speed up the cycle. So if we replicate the water cycle and this artificial transpiration, not only will we create more efficient greenhouses, but we will make vertical farming possible and space farming feasible. Also, the cycle can be used to move water passively and as well as a new hybrid source of renewable energy. Alright, so let's review the numbers. For a 90 foot by 20 foot greenhouse, it costs them $12,000 a year for heat and electricity. BluHouse Systems cuts heat and electricity by at least 20% of that cost, saving $2,400 a year. So the system costs about $3,200 to install, which means that the system will pay for itself within the first year and a half. So to get to a fully matured venture, we split up our stages into 4 stages, a 4-year cycle. So the first stage is prototyping, which we would use the $7,500 we got from the Ag Springboard to develop prototypes, the BluHouse prototype as well as the artificial leaf prototype. We've already received $500 from the Line Launchpad to develop an artificial leaf. So the outcomes of the stage 1 is a complete BluHouse prototype, a complete artificial leaf prototype, and research and development. Begin in 2016, and we will have the BluHouse system 1.0 completed. We'll sell to the first customers, and we are applying for Department of Energy grants that will help our venture, and we'll have further research and development. For stage 3, for 2017, we'll have a BluHouse system 2.0. Our goal is to have 25 units produced and sold and have an artificial leaf patent. For stage 4 in 2018, we want 100 or more units produced and sold, an artificial leaf license, and we'll expand to other markets and applications. We'll do vertical farming and space farming research and case studies. And that is how we will get to a fully matured venture. So this is our 4-year projection. However, it's based on 3 major assumptions. First is that we'll be working with greenhouses of the same size, the 90 by 24 foot greenhouse, which in reality will not be the case. Each greenhouse will be a little different. Second is that we will be producing and selling the units that we said that we will produce. And thirdly is the overhead costs. From right now, it is hard to calculate our overhead costs from our standpoint, but as our venture becomes more mature, it will vary drastically. So that is BluHouse, replicating the water cycle in a closed loop environment. We hope you enjoyed the video and thank you for watching.